Linear functions. The objectives here are that we are going to characterize linear functions, determine the intercepts and slope of a linear function, translate between forms for the equation of a linear function, apply linear functions to practical situations, and find the equation of a linear function given a point and information about the slope. So starting off, let's look at some tables of linear functions. What's the pattern in the y value for each table? First, we need to notice that we have evenly spaced inputs. We have to have that in place first. Then we notice in the y, we go from 1 to 3, 3 to 5, 5 to 7, 7 to 9. So we're adding 2 every time. Okay. Here we again have evenly spaced inputs, and we're going from 5 to 2, 2 to -1, -1 to -4, and -4 to -7. So we're subtracting 3 every time. So in this way we see that these are linear functions outlined in the table. A function is called linear if we always add or subtract the same amount from one y value to the next for evenly spaced inputs. Again, the key is that we have to have those evenly spaced inputs. Another concept we want to review are the intercepts of a linear function. Find the intercepts of the linear function. Let's look at what intercepts are. If I have a graph, doesn't matter what kind of graph that's going on, okay, all of these points that are on the x-axis are x-intercepts. Now, in order for those points to stay on the x-axis, the y has to be 0. So every one of these, we could make up some coordinates for them. Every one of these has a y part of 0, no matter where you are on the x-axis. So that gives us the idea that we need to make our y 0. If we can force the y to be 0 and then solve for x, we will know where that point is. So here, 5 times 0 is 0. That gives me 2x equals 7. Dividing both sides by 2, I get x equals 7/2. So we don't stop there. We still want to make sure that we put this as a coordinate. The coordinate is 7/2, 0. And it's important that we write it like the coordinate that it is. It reinforces the fact that we made y 0 in order to get the x of 7/2. A very similar concept for the y-intercept. You look at the y-intercepts here. They all have something in common, and that is that the x is 0. This is a 0, -2 probably, and a 0, +2, a 0, 4. If you don't want to veer left or right off of the y-axis and you want your graph where it's intercepting the y-axis, then you must force the x to be 0. So that's what we'll do in our original equation. Replacing the x with 0, we know that 2 times 0 is 0. So that gives me a -5y equals 7. And dividing both sides by -5, I get y is -7/5. Again, we're not finished there. We want to make sure that we put this as a coordinate so that we can see it has x is 0, gives us a y of -7/5. Let's talk about a certain format for a linear equation is called the slope-intercept form. Slope-intercept form of a linear equation will be y equals mx plus b. M is the slope and 0b is the y-intercept. In this example, we have y equals 2/3 x minus 6. I know that my slope, m, is 2/3, and 0b is the y-intercept, so your b right there is your b part of the y-intercept. Your y-intercept is 0, -6. And then we can use that information to graph 0, -6, and a slope of 2/3, up 2 and right 3. And there we have a nice graph of that line with slope 2/3 going through -6 on the y-axis. Here, let's graph the line 2x minus 3y equals 6 using slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So I'm going to need to take this equation and solve it for y. First thing I want to do is subtract 2x from both sides. That will give me a -3y equals -2x plus 6. Then I'm dividing both sides by -3. That gives me y equals a positive 2/3 x minus 2. From this, I can tell that my slope is 2/3 and my y-intercept is 0, -2. Okay, so 0, -2, we want to start with a point, and then our slope says rise 2, run 3. Rise 2, run 3. As many as you want. Didn't quite make it there. And now we can go ahead and draw a nice line through the points we have there. And get some arrows on the end, and there is your linear function. There's another form for a linear equation called point-slope form, and that is y minus y sub 1 equals m times x minus x sub 1. You do need to know this. This is not a formula that's going to be given to you, and you don't need to be too worried about it, because if you can remember your slope formula, slope being y sub 2 minus y sub 1 over x sub 2 minus x sub 1, well, we're going to be using this formula when we have a single point, so we don't have that second point, and a slope. If we can take this formula and multiply both sides by x minus x sub 1 to clear the fractions, we'd have m x minus x sub 1 equals y minus y sub 1. There is your point-slope form. You can also use it as a formula. Again, m is your slope, and x1, y1 is just a point. And the good thing about this one is that it doesn't have to be a special point like an intercept. It's just any arbitrary point. So we're ready to find the equation of a line with slope 2/5 and the point 5, 1. And we'll put our answer into slope-intercept form. Okay, so this is not an intercept. We know this because this is not 0. If this was 0, then we would know we have a y-intercept. That's not the case here. This is just an arbitrary x sub 1, y sub 1 point. And my slope is 2/5. That's my m. So let's put it into our point-slope form. That's y minus y sub 1 equals m times x minus x sub 1. Now this is point slope form of the line, but they asked for us to put it into slope intercept form. Slope intercept form. So remember that means y equals mx plus b. We just need to solve this equation for y. So we'll have to go ahead and distribute the slope, and I'm going to add a 1 to both sides, so y ends up equaling 2/5 x minus 1, and that is the slope intercept form of the line. They could also tag on another question for this and ask what is the y-intercept, and you would know that it is 0, -1, because there's your b right there is a -1. Alright, let's find the slope-intercept form of the linear function with points 2, 1, and 4, 4. So a lot of times the form that they're asking you to get your function into will give you some clue of what you need. We need the slope to be able to get the equation of this line, and we don't have that. So we'll go back to our slope formula and use the 2 points that we have to get a slope. So slope is going to be our y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's 3/2. M is 3/2. Now we need to have the y-intercept. Neither one of these are a y-intercept, so we're going to need to use the point slope formula because these are just two non-special points, and use one of the points with the slope with the point slope formula, and then solve to eventually get it into the slope intercept form. So I'll write the formula down again here. It's y minus y sub 1 equals m times x minus x sub 1. So when we have a y, we just write down y minus, and when it says y sub 1, we actually substitute the point, the y from the point. I'm going to go ahead and use this one. Doesn't matter which point you use. So y minus 1 equals 3/2 times x minus 2, and I'll go ahead and multiply through, distribute that 3/2. So y is 3/2 x minus 2 after we add 1 to both sides, and that is the slope intercept form of that linear function. Now there's another form of a linear function, and that's standard form. Standard form is ax plus by equals c. A is positive, and a, b, and c cannot be fractions. Basically, we have x and y both on the left side. There are no fractions for a, b, or c through the whole function, and you have to lead off with a positive number. A must be positive. So we're going to find the equation of the line with slope 2/5 and the point 5, 1. Again, we've been given a slope and a point that's not the y-intercept, so this is an x1, y1 point. We have to use point slope form, and they actually want our answer in point slope form when we're done, so that's fine. I'm going to have y minus y sub 1 equals m times x minus x sub 1. Now we're going to take that equation and find the standard form of the same line. So remember, standard form, your x and your y need to both be on the left side and your constant stays on the right. So let's go ahead, multiply through. Okay, and I need to subtract 2/5 x from both sides and add 1 to both sides. And I can't have a fraction, and I also want the x to be first, and I want its coefficient of -2/5. Can't be a fraction, it can't be negative. So I'm going to multiply through by -5, and I will rearrange that at the same time. Multiplying through by -5 will give me a 2x minus 5y equals +5. And there is our standard form of the same equation. Alright, let's review a little about horizontal and vertical lines. This is a vertical line going through an x value of 2. You'll notice here every point along that vertical line has an x value of 2. The y varies, but the x is always 2. So what better equation to represent that line than x equals 2? And we have this one as well, the horizontal line. And if you notice, it doesn't matter what the x is here, the y is always the same. The y here is always 3, so what better equation to represent that horizontal line than y equals 3? And this is the same with all vertical and horizontal lines. The vertical line is going to be x equals some constant, and the horizontal line is going to be y equals some constant. Now we have other information here about the slope. This says that the vertical line has undefined slope. So let's investigate that a little further. If I have this point here of 2, 3, and maybe this other point of 2, -2, and I put that into the slope formula, 3 minus -2 over 2 minus 2, you'll see I get 5 divided by 0, which is undefined. And that is always going to happen because you're subtracting your x's on the denominator, and if your x's are the same, then you're going to get 0 on the denominator. The vertical line is undefined slope. This says that the horizontal line always has a slope of 0. Again, we can verify that. Let's say we use this point of -3, 3, and 5, 3. And the slope is 3 minus 3 over 5 minus -3, giving me a 0 over 8, which is 0. And that's always going to happen because if your y values are the same, and those are the things that are being subtracted on the top of the slope formula, it's always going to be 0. So the slope of the horizontal line is 0. Let's find the equation of the line going through the points 3, 5 and -1, 5. Now we could try and do this the same way as we did in an earlier problem with 2 points, but I just happened to notice that both of the y's are 5. If the y's are both 5, that's going to be a horizontal line. And the equation for that horizontal line is going to be y equals 5. No need to do more work than necessary. Now let's find the slope-intercept equation of the line of slope 0 containing 2, 1. Again, you don't want to do more work than you need to. Only a certain type of line has a slope of 0, and it's that horizontal line y equals 1, because here y equals 1, and that's it. Here we have an example of a linear function in verbal format. We had that in an earlier section just with points. So let's see if we can come up with a linear function for this situation. A plumber charges $50 for a house call plus $30 per hour. Express the cost C as a function of the number of hours H the plumber is on the job. So they are, instead of using XY, they're using HC. The cost is dependent on the number of hours spent on the job. Let's make a table, H and C. And let's say that the plumber makes the house call and he's there for 1 hour. So the cost is going to be $30 for being there an hour plus $50 for the house call. Next one, let's say he's there for 2 hours. So he's going to pay that $30 per hour charge twice and the $50 just for making the house call. Let's say he's there for 3 hours. He's going to make 3 $30 charges for 3 hours plus $50 for the house call. So you can see the pattern here. You can even write in the 1 up here if you want to do that. But if we're there for H hours, then we're going to have H times 30 plus 50. So our cost is going to be 30H, just make it look a little nicer by putting the coefficient in front of the variable, plus 50. There you are. And here's another linear type situation. After 30 minutes, a pool's volume has been raised to 2,000 gallons of water. After 50 minutes, the same pool has 2,200 gallons of water. If the pool continues to fill at a linear rate, write the function that models how much water W is in the pool after M minutes. So again, I think it's a good idea to write your variables. M is in the X position, W is in the Y position. Now if you know that those are the positions for your variables, then you can make some data points. We have 30 minutes corresponds with 2,000 gallons of water. So 30 minutes corresponds with 2,000 gallons of water. And we have 50 minutes corresponding with 2,200 gallons of water. And they're larger numbers than we've seen so far, but this is a case where we have 2 points. Remember, we need a point and a slope. We have more than enough points, but we need to get our slope. So let's start with slope. Slope is 2,200 minus 2,000 over 50 minus 30. That's going to give me 200 divided by 20, which is 10. Okay, so the slope is 10. And if you wanted to put a unit on that, it'd be gallons per minute that are being added. I think they might need to get another water hose. But we've got slope now, and we can pick just one of the points. I tend to like to pick the point that is smaller numbers. So I have y minus 2000 equals 10 times x minus 30, and that's your point slope form. Generally, you're going to want this into a function form because you might be putting this into some kind of graphing program or whatever, but this is your point slope form. And if we wanted to get it into slope-intercept form, then we just solve for y, distribute the 10, and y is going to be 10x minus 1700. Okay, now what's interesting, this is a slope-intercept form. What's interesting about this is that you can now see what the y-intercept is, which is nice because this is the y-intercept, 0, 1700, and think about what that point means. It means that at 0 minutes, that pool had 1700 gallons of water in it. Okay, so it didn't start empty, it had 1700 gallons of water in it. Let's review a little about parallel lines. Let's look at the slopes of these parallel lines. What is it that you notice? I'm looking at these and I see from here to here, I have moved up 1 and right 3. So it was a rise 1, run 3, and here, rise 1 and run 3. So rise over run is 1/3. The slopes are equal. In fact, the slopes of parallel lines will always be equal. Now I want to find the slope-intercept form for the line through -1, 3 that is parallel to y equals 2/5 x minus 2. Remember, to get the equation of a line, you need to have a point, we have that, and you need to have a slope. Well, they're giving you information about this other line so that you can borrow it. If we're parallel to that slope, then I know I'm going to have the same slope of 2/5. Again, find the slope-intercept form. I'm not going to be able to start off with that, but I can start off with the point slope form and eventually work my way to get to the slope-intercept form. There's point slope form, and I'm going to distribute and I'm going to add 3 to both sides. So y equals 2/5 x plus, we're adding 3, that's the same as adding 15/5, so that's 17/5. Okay, so when they are giving you this information of being parallel, they're giving you some kind of information about the slope that they want you to use. Perpendicular lines. Graph and compare the slopes of the perpendicular lines. Here I have y equals 2x minus 1, 0, -1, the y-intercept, and my slope is 2 over 1, so I'm going up 2, right 1, up 2, right 1, up 2, right 1, or I could go down 2 and back 1. And those points are going to connect with a nice straight line here. And let's graph the next one. We have a y-intercept of 0, 1.5, and our slope is down 1, right 2, down 1, right 2, down 1, and right 2. And you'll notice we did graph perpendicular lines. And what do you notice about the slopes of those? This line is increasing. This line's going to be decreasing. So it makes sense that they have opposite signs. And you'll notice that the numbers themselves are reciprocals. So the slopes will always turn out that way. They'll always be opposite in sign and reciprocal numbers. Here we want to find the slope-intercept form for the line through 1, 2 that is perpendicular to y equals 1/3 x plus 7. Okay, so remember we have to have a point and some slope in order to get the equation of a line. The reason they're giving us this perpendicular word is to say we have some information about the slope. So the slope here is 1/3, but we want a slope of a line that's going to be perpendicular, so that'll be opposite in sign and reciprocal number. So I'm going to be using this information to get my slope-intercept form for the line. So y minus y sub 1 equals m times x minus x sub 1. And again, I just need to simplify this and solve for y. I'm going to add 2 here at the end. And there is my slope-intercept form for this line that's going through 1, 2 and is perpendicular to this other line.